In this video, we're going to talk about the ambiguous case of the law of sines. It sounds like a mystery. So in the last video, we mentioned several different types of information that could be given to you about a triangle. And we kind of wrote these out in the sort of like a side angle side, right, abbreviations that we've seen probably in the geometry class. Okay, well, the one that leads to an ambiguous case using the law of sines is the side-side angle case. So when we do this case, we could have a couple things happen, right? We could get facts that don't actually lead to the construction of a triangle. So we could get 0 triangles. We could get facts that do indeed give us 1 triangle, and we could solve for the rest of its pieces. Or we could get 2 possible angles, which then generate 2 possible triangles. And so we would kind of finish out by writing out all the possibilities for both triangles. These were some helpful facts that were listed in your book that I think will help us identify, kind of keeping them in mind so that we can decide which of these cases is happening, right? So number 1, the value of the sine has to be between 0 and 1. If it's outside of this region, right, or these values, then we won't be able to calculate the angle with that sine value, right? Because the function sine is only defined for an angle that gives a value between 0 and 1. Well, in our case, okay, I guess I shouldn't qualify that, right? Technically, it could go from -1 to 1, but in a triangle, we're not going to have angles bigger than 180 degrees. And so if you think about the unit circle, for angles between 0 and 180, the value of the sine is between 0 and 1. And so that's going to be true for a triangle. When it's 1, right, that means we've gotten an angle of 90 degrees. So that's going to mean we have a right triangle. Okay, so that's the first fact. Second fact is that the sine of an angle is also equal to the sine of 180 minus that angle. This is talking about a reference angle. Let's draw a picture. Okay, so if I have an angle right over here, the sine value on the unit circle is going to be the same as the value of the sine on this side of the unit circle. And so this is saying that, right, this angle and the angle that goes all the way to here have the same sine value. So we might want to consider that. That might lead us to having 2 possible triangles. So we do need to think about that. Okay, and then number 3, in a triangle, the smallest angle is going to be opposite the smallest side. The largest angle is going to be opposite the largest side. There's 3 of them, so that must mean that the middle angle is going to be across from the middle side, right? So if those don't line up, then that causes a problem, and we've got a solution that's really not a true solution. So we need to kind of watch out for that as well. Okay, so I chose a few examples, hoping that I can show you each of these scenarios. So let's try that out. So here's the first one. I probably should not have labeled them so that we could have some mystery here, but I didn't do that. All right, so this is from your book. This is number 17. We are given angle B is 74.3 degrees. Side A is 859 meters. And side B is 783 meters. Okay, so notice this fits that side-side angle. It's not the angle in between, right? It's It's an angle sort of outside the two sides. Okay, so we do have an angle side pair, and we need that in order to use the law of sines. So since we have that pair and we have this side length, it makes sense to go and solve for angle A. So let's try to do that. Okay, so we'll have the sine of angle B, which is 74.3, over the side length of side B, which is 783. That must be equal to the sine of angle A over the side length across from that angle, 859. Okay, so if we solve for the sine of A, we would multiply both sides by 859. So let's put that into our calculator. Again, I just did the last video, so I mentioned this there, but you do need to make sure we're talking about degrees, so you do need to be in degree mode. So you would hit mode and degree should be highlighted. I already checked that, so I'm not going to do it again, but it is worth thinking about each time. Then we're going to divide by 783. So the sine of angle A is 1.056. Okay, so maybe you can spot the problem here. If you didn't, okay, let's say you didn't, maybe you tried to find the inverse of 1 point, right? That's what we would normally do. So we'll do sine inverse of 1.056. And it gives us an error, right? Why is it giving us an error? Because the value of the sine has to be between 0 and 1, and this value is bigger than 1. And that's causing us a problem, right? All right, so this triangle does not exist, right? Or this is not a triangle. It's not a triangle. However you want to phrase that. Okay, so that's one way that that can happen. There are a couple different ways. I'm not going to get to work out every single type of problem for you, but this is one of the ways, right, where we can say, hey, this information you've given me does not actually form a triangle. Okay, then there is the possibility that we could get two possible triangles with the information we've got. So let's try this one. This is also from your book. And this problem, angle B is 39.68 degrees. Side A is 29.81 meters. And side B is 23.76 meters. Again, this is that side angle. Okay, so again, we have angle B and we have the side across from it. And we have the side across from angle A. So it makes sense to try and solve for angle A. So the sine of angle B, which is 39.68 degrees, divided by the side length for B. That must be equal to the sine of angle A divided by the side length for angle A. Okay, and just like before, we could multiply this over to the other side. All right, then we would want to put this into our calculator. So we get 0.801. Okay, we don't have the problem we had in the last example, right? This is definitely between 0 and 1, which is fine. So now we want to figure out what angles are possible, right? So if I do the sine inverse of 0.801, I'm going to be a little more precise this time. If you do second and then you push the negative key down there at the bottom, it'll put in that whole number with all the decimals, right, without rounding. So if we do that, it gives us A. So A would be 53.2, how many digits we're doing? 4 digits, right? 0.23 degrees. All right, so that's one possibility. There is another possibility, right? And that is 180 minus 53.23 degrees, which would be 126.77 degrees. This would be a reference angle, right? Think of the unit circle. If this were 53.23, then over here would be 126.77, right? And these would both have the same sine value. Okay, so notice this angle is bigger than this angle, which this side length is bigger than this side length. I think that makes sense. Same for this one, right? It's bigger. Okay, so let's do the two possibilities here. So A could be 53.23 degrees, or A could be 126.77 degrees. Now that we found angle A, let's go back and find the other pieces of the triangle that we don't have. In this case, we don't have angle C and we don't have side C. So first, let's find angle C. So we can add up, right? We have one angle already, 39.68. We just found this one. All right, so if we add that up, and then we subtract it over. I'm just going to do it all at once. I hope that's okay. That's going to give us 87.08 degrees. Okay, if I do the same thing over here, let's do this. We're going to have 39.68 degrees. plus 126.77 degrees plus angle C that's going to give us 13.55 degrees. Okay, so now the only thing left is to find side C. So now we need to use the law of sines again. So we've got the sine of angle B over the side length, 23.76, must be the sine of angle C, which we just found in this case to be 87.08 degrees, over the side length C. So if I multiply this side by C, that's going to leave the right-hand side over 1. And then I'm going to multiply it by 23.76 and divide by the sine of 39.68. So we'll put that into our calculator. That gives us 37.4 significant digits. So 37.16, and we're in meters this time. Okay, now let's try the second scenario. Again, we'll do angle B. And now we'll have the sine of 13.55 degrees over C. All right, if this is the case, this would be the smallest angle in the triangle, so this should be the smallest side. So we should definitely check that to make sure we did it right. Okay, so when I multiply C over to this side, this is going to be over 1, and then I'm going to multiply by the reciprocal of this fraction. Okay, and then divided by the sine gives us 8.71, which would indeed be the shortest side. Okay, 4 significant digits, so 8.719 meters. All right, so 2 different triangles, 2 different values for this angle A, which led to 2 different side lengths and 2 different third angles. Right, so 2 possible triangles altogether. Okay. One more. This time we have angle A, it's 42.5 degrees. Side A is 15.6 feet. And side B is 8.14 feet. Okay, same, we have side-side angle, right? We do have that angle side pair that we need for the law of sines. So let's first solve for angle B. So we'll have the sine of angle A, which is 42.5 degrees, over the sine of angle B divided by 8.14. Okay, and we want to solve for B, so we're going to multiply the 8.14 over to this side. So let's calculate what that is. That's going to give us 0.3525, we'll say, is equal to the sine of B. Okay, so now we want to find B, we would take the inverse sine of this value. So second sine will give us sine inverse, remember, and I said second negative is going to give us the answer, the previous answer, so we don't have to round it yet. So that's going to give us angle B, which would be 20 point, we're doing 3 significant digits, so 20.6 degrees. Okay, if there were a reference angle, it would be 180 minus 20.6, which would be 159.4 degrees. Okay, we really have to think critically about these, right? And make sure that they're possible, right? Now this is just a generic triangle that's certainly not drawn to scale, but if B were 20 degrees, 20 plus 40 plus something else could add up to 180. But if B were 159, let's round it to 160. 160 plus 42 is going to be more than 180, right? Let's write that down. So 159.4 plus 42.5 would be 201 degrees, which is more than 180. So for this reason, this is not an option. Right? Did we get 2 possibilities? Yes. But one of those possibilities is not going to work. Right? So does this sine value give us 2 angles? Yes. Are both of those angles going to generate a triangle? And one of them is, but one of them is not. Okay, so that means that this is the only value we can get for B. So there's just one possible triangle. Okay, so let's carry on then and find the rest of the parts, right? So we have angle B. We need angle C and side C. So, well, let's calculate angle C. They all add up to 180, so we have 42.5. We have 20.6. plus angle C is equal to 180, right? This makes 63.1 degrees. So we're going to get 116.9 degrees. Okay, which really we're using 3 digits, so we should actually write it as 117 to do our 3 significant figures. Okay, so that gives us angle C. Sorry, I should have written this nicer. Do that. Okay. Now we need to find side C. So we'll go back to the law of sines. I'm going to go back to angle B again. Or no, sorry, angle A this time is what we were given. I like to use what we were given just in case I made a mistake. Sine of angle C. To run out of ink. Okay, so we're solving for C, so I want to multiply the C over to the other side. And that's gonna, and then I'm gonna multiply by the reciprocal. And then I'm going to put that into my calculator. Oops. So I'm going to get 23 significant digits, so 20.6 feet. Well, I hope this gave you a really good idea of what the ambiguous case could look like. I don't think we looked at every possible scenario, but I did try to hit on some of the major ones that might pop up. So you will definitely want to try this out, practice it, look for problems that have that side-side angle so you can try it out. Good luck, and we'll see you in the next video.